It was like e to the -5/2.
Just sometimes. This is when you sit next to two physics majors over here.
Words, they're not part of this major.
What?
Physics majors. Chemistry majors, it's different.
Right.
I'm also a chemistry major.
Yeah.
Oh, you're also doing
All
a
of
major
it.
of chemistry?
Yeah.
No.
Oh, you're not like him doing a minor.
No.
I mean, I'm probably
Okay,
going
no,
to do a minor.
He's math. Though.
Yeah, I'm math physics, which
Yeah.
or a computer science minor.
Oh.
So really, he should be the one doing this Eigenvalue.
That's right.
Okay, thanks for coming and thanks for intense investment in your own education and success of the course by sending materials in time. So we are in the courses of physical chemistry, and there is an idea that math is so complicated that we need to replace analytical solving by programming, which is considered as a shortcut. MATLAB is the simplest way of scientific computing, therefore we are covering some basic elements of the scientific computing that will help us to progress like a rocket through the course. Here is the list of presenters. Special thanks to those who didn't find time to prepare and send, if you give more time to others. Those who present will get a general credit or more generous than who works. And the materials are arranged as follows. So basic skills, work with vectors and matrices, visualizing outcome of calculations, and some very basic programming. The work here is arranged as follows. The practical protocol. So you approach the podium, find your number and name here. So they all are numbered in the ascending order, and they have, the files do have your names. Then you select name, double click, and if you do not if you use other systems other than PC Windows, here should be a symbol to start presentation, or in slideshow you can just start from the beginning. With this, I would like to announce the another important thing. Please stay within 3 minutes. If you are violating this limit, I will come here and start pushing away from the stage. So with this, I would like to announce first speaker, Bergh, who will tell us how to use play with complex numbers in MATLAB. What is yours? And if you need more of printed materials, I have them here.
Okay. So basically, imaginary numbers, complex numbers. I pressed a button that I shouldn't have. I don't know what I did. Oh, you guys can't see it, so that's okay. Okay. Yeah, so basically what we know is that I equals the square root of -1. Right, so everybody probably knows that. And you can express this as a complex number with a real portion and an imaginary portion. So, oh, there you go, that's what I saw. It's a real portion and an imaginary portion. And MATLAB actually, MATLAB denotes this portion, the real portion, as the cosine of x, and this is the I sine of x. So like Euler's formula. And then basically it follows a pattern too. So if you say like I squared, that equals -1, I cubed is square root of 1, I to the fourth, that equals 1, then it just goes in rotation. And i's can get kind of complicated because of that, because you're always going to have like a flipped number or a square root somewhere. So basically what MATLAB does is it uses Euler's formula that kicks out a complex number for you. So basically up here we said that like I define my x to be pi over 4, and then like your sine and cosine squared, that equals 1, but if you throw an I in there, then that totally screws things up with an e to the -16. Basically, this is just saying that, talking about exponentials now. So, like adding e to the x times e to the I is the same as e to the x plus 1, right? And I messed up there, so it got redacted. And then basically it's also the same as the Euler formula, which is e to the x cosine y plus I sine y. Right? So that's the same thing. So it's just a simple calculator, and it's Euler's method. And that's a wrap. Thanks, guys.
Okay. Just in case someone has questions, do not leave. Questions? How to extract imaginary part from complex number?
Oh, you're questioning me. How do you
Yes.
extract an imaginary part out of a complex number?
Yes.
That would be the second.
Yes,
The
but
part
if
of
you
it.
if you are writing a code, you are not looking on your data every time.
Okay. How
You
do
have a variable, and you want to assign its imaginary part to a new variable.
I want to assign its imaginary part to a new variable. That
So
I
you-
don't know.
So you type IMAG, like shortening of imaginary of z, and then it will return the imaginary part. Okay, let's thank Jan once again for being great. And the next presenter is, please comment, run it yourself. So Megan, she will continue our journey into the world of MATLAB and will tell how to define functions.
Yep. So I'll be defining functions. The first basic way to do so is with the linspace function, in which you define what number you want to start at, what number you want to end at, and how many you want. If you don't define how many you want, MATLAB's default is to give you 100. And then you can define your own function by clicking new and then the function, and that brings up this editor screen in which you can input arguments and name your own function. So for the first one, I defined a pchem function, and I just want it to give back to me physical chemistry. So if I type that in and hit enter, it returns physical chemistry. And then if I want to define an input, I can define x1 as a variable. I want it to add 20, and that would give me the whatever value I put in the parentheses plus 1. That would give me 25. Then I can also define a variable through linspace. In this case, I'm defining from 0 to 2 pi with 100 increments. And the function y equals sine of x. I want to figure and I want it to plot with x and y. And that gives me the sine function.
Okay, let's thank Megan. Anything you wanted to ask? Please.
I guess I'm curious, like your physical chemistry example, is that you just like assigning a value to whatever you want? Okay.
Yeah, you can-
I wasn't quite sure what that was,
Yeah.
but okay.
Okay, thanks for being active in questions and answers session. And next is Aaron Polenski, who will present on further extension of the concept of functions in MATLAB, and he'll tell a story how to deal with differential operations.
Yeah, so alright, so in MATLAB I just started off with the basic derivative function. Best way to do it in MATLAB, there's no like complete straightforward way to do it. You have to assign each part of the derivative function and assign it a specific name. I have an example right here. So you have to start off with how you want your increments done, and you have to set your x equal to something. That's your domain, and then you find your range of your, with like setting it equal to x. And then if you want to do the first and second derivative, use the differential equation over the h. And then that just shows you plot it there with all your lengths and how big you want your actual chart to be. The big actual like differential part is like the key derivative aspect of it, and you just put it over h. And there was an example. This is the example of the one that was up there. The blue was the original starting function. The red is the first derivative, and the black line is the second. And then when you're doing an integration, you start off with plotting, like you have to assign some function like before. So this one is cosine of x from pi to pi. And then you plot and then integral of your x. And this one is just like a straightforward full integral. If you want to do a rate, like a summation of it, you can do it that way. And you can also change the number of bars you have by adding it after your f. So like if you want 20 segments, or if you want more than that or less than that, it'll give you all those segments, and then you can see how much area is lost or gained through the summation. And
Okay, but thank Aaron. Do not leave. You have
Yes.
questions.
So can you explain the code there in red?
oh yeah, so this is just the plot of the sine graph. So f was, I think, cosine, and so that's what the integral f, 20 marks, and then this is showing the
What is
error.
plot colon colon?
Is it a MATLAB code or maybe some other language?
It's I'm pretty sure it's MATLAB. I got
Did
it
you
from
did you
MATLAB.
did you run it yourself?
No, I didn't
Um,
run
So the main idea here now is fine. We still are on learning curve, but main idea of this presentation is that you share your own learning curve and your experience. Like going online and finding something copy pasting, it doesn't count. It's like telling what I did and what story of success or maybe failures. Okay, more questions, please.
Can do you have to like graph it to find the derivative, or can you just have it like? Because I see for example your third slide, you have all these
Yeah.
domain range things, which I'm assuming are there for graphing purposes. But
This one?
when I do a derivative on paper, I don't necessarily think about the domain or range or anything like that.
That's
Is
what. Yeah, you just need to put that in for MATLAB's actually
to actually figure out the derivative. Okay.
In order to plot it.
Yeah, to apply, because that's why I started off with that example right away, because there's no you can't just put a function in and then
Say take the
Yeah.
derivative. Okay, that's
So you
right.
gotta,
That's basically what I was
step
asking.
it all out and do each piece by piece.
Because the function has to be defined on a certain domain or
Yeah.
to be differentiable.
That's why you have to set up bounds.
MATLAB only likes numerical answers.
Yeah.
So there are available codes for analytical derivations, but it is not our case. We are simple guys right now. If there are no more questions, let's thank whom we are thanking? Aaron. So next presentation is by Andrew Olson, and he will continue the story of MATLAB with more direct purpose of the MATLAB, working with matrices and vectors as a simplest form of matrix. So he will tell something about how one can multiply vectors and what else one can do with them.
Alright, so I'm going to talk about vectors and just the basics of that. So first you want to know how to enter in a vector. So what you're going to do is simply enter it in exactly as it's shown. So A equals, then columns, and then enter any numbers for a column vector. And then for a row vector, enter in B equals, and in between the brackets, put in your numbers. So if you want to do a scalar product, you're going to want to do your row vector first, multiply it by the column vector. And if you want to do a diadic product, you're going to do the column vector first, multiply by the row vector. And And then the Dirac notation, or the bracket notation, that's essentially this notation right here. And it's essentially just a shorter-hand way of entering in like vector multiplication and stuff like that. So, yeah, any questions?
Okay, let's thank Andrew for being extremely brief. And other questions?
Does MATLAB actually accept the bracket notation, or does it?
I didn't get a chance to test it,
Okay.
but I believe it should, because it's included with this.
Yeah, that would be a lot easier.
Yeah.
Maybe it does, but it is not. I am not aware of this.
Okay.
I would use just any. You can call your variable like bra and cat.
Yeah.
But then you need to understand what you understand under this. And conversion from bra and cat, you just do transpose.
Yeah.
More questions to Andrew? If not, let's thank him once again. And the next presentation is by Austin Brewer, who will continue the main, telling us about how to pursue the main goal of MATLAB, working with matrices. And he will tell how one can characterize and play with them.
All right, yeah, so play with them is exactly what I did. So I worked with matrix functions. This is pretty much a summary of what Andrew was talking about, how to actually make a row vector and a column vector are the two examples right here. And then you can do all sorts of different, mathematical operations with them. So you can add the vectors, you can subtract them, you can follow things such as the cross and dot product. And then with the certain dimensionalities, like he was talking about, there are some restrictions that allow you to do cross dot or even division. So there's some different ways that you can play around with MATLAB in that sense. So then the three main topics that I wanted to cover is transposing. So the basic idea of transposing is that you want to actually represent some kind of transformation or transposition, whether that be like a rotation or scaling with your matrices. So in terms of the matrices itself, really what it is it's just keeping the main diagonal and then flipping the other diagonals. So in the MATLAB software, you're just going to use that kind of comma on whatever your matrices is to define your new transposed matrices. Following this, a different form of transposition is just the determinant function. And if you follow the actual definition of determinants, when you have a 2x2 matrix system, it's relatively easy. It's stuff that we've done since like high school mathematics. But then once you get to three-dimensional matrices, it starts to become a little more complicated just to do by hand. So using this to find actually things such as area, volume, etc., for these actual values of our matrices and what they physically represent is a lot easier to do in MATLAB just by using the determinant and then the function of whatever your matrices is. And the last one that I wanted to talk about is the inverse matrices. This is again just another transposition or transformation where it's looking at the matrices or the physical representation of the matrices in a different sense where you're actually inversing it. In MATLAB, super simple, you just inverse whatever your matrices is and we'll find the inverse for you. But then you can also use, like I did with, this is my fun conversion here, where you can actually solve the inverse in another form using the determinant function, and vice versa, you could use the inverse to actually solve for the determinant if you looked up and followed the definition of what a determinant and inverse function is. So, any questions?
Okay, let's thank Austin. I see questions.
So on your first content slide, you have a dot product displaying a vector or a matrix.
I'm sorry, what was that?
On your first content slide, you have a dot product ending up as a matrix.
Yes. So I guess I might not know the full definition of dot product, but it's just taking the dot product between two vectors, and it did output a matrix, so I guess.
Should be a number though, right?
Yeah, because the dot
As a
product should
scalar
always end up
function?
as a scalar.
You know, that's a good question, but I did look some stuff up, like the videos online and everything, and they said that to do dot product would be to use that kind of formula in MATLAB. And I did try it.
Do you
out.
understand the purpose of the X period?
Well, I think-
Oh, yeah, because that, I think,
Takes each entry and
yeah,
multiplies
that goes like
each.
element by element, I think. I figured out when I was screwing around with it.
Yeah,
Okay.
Is everyone is clear what London told right now?
Yeah, no, good catch. I see it.
If not, give some signs or just repeat. Please listen to what London is telling.
So when you have like your matrix followed by a dot, and then you, I guess, do something in general, because I was using exponents when I did it, it does whatever your operation is, except element by element instead of like matrix multiplication or matrix exponentiating.
Is it more clear for most of us? Let me tell the same thing as you, just maybe translate into maximally simple. If you do not need any vectors and matrices, you need just arguments of functions, which are stored as an array. And then you need to take like x is your array, and then you need to take x squared or some polynomial. If MATLAB will think of x as an vector, it will start making this strange matrix algebra, like converting your linear line of numbers into whatever single number or matrices. To avoid it, one can make a note that please process this set of data just as a set of numbers, which they call element by element. Like if you need to do x squared or x by x, it will give you like either a number or a matrix or an error. But if you do x dot star x, it will be new matrix, new array, which will have the data of x squared. So I'm just translating what London told. Okay, more questions to Austin?
On the same slide, you have like vector addition, subtraction, and cross product.
Yep.
But when you do vector addition and subtraction, it looks like you're ending up with another matrix. And so it looks like you have been doing a matrix addition and subtraction.
You know, I'm not gonna lie, I'm not the best with matrices and like what functions they should actually be
If
producing.
you're using
but-
this row vector and column vector, those are C and D, and use it X and Y. So unless you use the C and D as your X and Y, you might have had a different ones that kind of gave us some weird things.
Yeah, I'm almost wondering if it was just matrices to begin with when you actually punched in the code there.
Yeah.
Sure. I'm sorry, I guess I don't really understand or really get what you're getting at. So matrices are still kind of new to me, so not the best with them.
We'll get through by practice.
Yeah.
For the sake of the time, let's thank Austin once again. And next in the program is Mark Almlie, who will tell us a little bit more about advanced operations with matrices.
I didn't get my slides printed out because apparently there was some email issues, so didn't get in on time. Okay. Alright, so I did eigenvalues and eigenvectors in MATLAB. And so to start with, I just solved for some, kind of came up with a simple matrix and solved for eigenvalues by hand. So let's actually go back because A times the eigenvector should equal the eigenvalue times the eigenvector. So with a fairly simple matrix, you just follow the formulas that found online, and you get the determinant of the lambda times the identity matrix minus your starting matrix, and that should equal 0. So you solve for that, and with that matrix, lambda was 5 and minus 1, and then you also solve. So the for each lambda, you get that lambda times the identity matrix is minus the original matrix times the, and then times an eigenvector should equal the 0 vector. And so for lambda 5, I got the first value of the eigenvector is equal to 1/2 of the second value. And then for minus lambda minus 1, it was a ratio of 1 to -1. And then so in MATLAB, just to prove, I did all of that just to prove that MATLAB is actually doing it correctly. And so if you type in v comma d equals the eigen A, v will give you the eigenvectors, and d will give you the eigenvalues, and they'll actually line up. So the eigenvectors for -1 are in the same column, or yeah, and it took me about an hour to realize that those ratios were the same as the ratios of the eigenvectors, because any vector along the line spanned by an eigenvector is an eigenvector. That's... Any questions?
Okay, let's thank Mark. Any questions about this advanced subject? So please repeat just for our memory. When you do this VD equals eig of 8, which of the matrices on the left corresponds to eigenvectors and which to eigenvalues?
V corresponds to the eigenvectors, and D corresponds to the eigenvalues, and then, so the first column in V is the eigenvector of the first column in D, associated with the eigenvalue of the first column of D, and the second column of V is the eigenvector associated with the eigenvalue in the second column of D.
Okay, yeah, thank you. It's last chance for questions. 1, 2, 3. If not, let's thank Mark once again. Last call for Luke Bowman. If no, then the next presenter is Beth Podoll, who will tell us how to visualize all these advanced and interesting things in a way more perceptible for human brain. So going from numbers to pictures.
Yeah, so I'm talking about visualizing matrix. So throughout today, I'm going to use the same A matrix. So this is what we would input as was said earlier, and this is what the MATLAB reads as my matrix that I'm using. So the first way that we can do it is to make a bar graph. So the command is just bar A. This gives you a vertical bar graph with the groups being m groups of n vertical bars. So that would be the rows and the columns on your matrix. The second way would be a 3D bar graph. So again, here's your command. You have bar 3 and A. This just gives you a more fully, like, 3D version of the same bar graph. So it's, again, the m by n matrix. The third way, we can flip it horizontal. So your command is now bar h. And this would be, maybe you want to see the distribution across the bottom. We can also plot it linearly, as was shown earlier. This just plots it in the y versus the x. So our command is plot A, and then we're going to enter, and we get our nice graph. And then, so those were all very simple concepts, or simple matrices. But obviously, as we get a more complex matrix, we can get quite more interesting graphs. So that's how we use it to solve our problems, is seeing a visual depiction of our problem.
Okay, good, thanks. And other questions about visualizing matrices? Questions 1, question 2. Question 3. So it was so crystal clear that no questions. But thank you once again.
Awesome.
So next presenter is London Johnson, who will continue our story of visualizations, but he will go from matrices to continuous functions and show the way how to show different mathematical objects in visual form.
So yeah. So basically the syntax with how you're going to want to try to make a function, I guess this is the only way that I knew how to do it when I was doing it, thanks to Dimitri showing us. So you enter in your variable, and this is going to represent a vector. So your first data point is going to be 0, and then every data point after that will increment by 0.1 until you pass this value, at which point your vector will terminate. So like in this case, you're going to have 1,000 entries in your vector, each of which represents a point at which to plot your function. So then if you're going to enter, you know, a one-dimensional function, you just have to put in some function of this variable. If you've got a two-dimensional function, you need to just put in some function of, you know, that x and some other y that you define, preferably over the same amount of elements. You can do it in different ways, but I really doubt that we would be doing that in this class, and it's not generally acceptable by all the functions, or all the plots, I guess. So then just for a standard 2D plot, you just have to type in plot x, and then y would be your function of x, so in this case just the sine of x. So it'll just plot it until your vector x ends, and then after that it just doesn't plot anything anymore because it doesn't know what to do. So then for a, I guess I'm not totally sure what the usefulness of this one is, but the plot3 command for a two-dimensional function will basically give you a line cutting through. I don't know if you can really see that, but this isn't actually, I suppose it is technically three-dimensional. No, it'd probably be two-dimensional actually, but it basically is just a line of a function slicing through the diagonal here. So then the, this one is surf is the command. Yeah, there's probably nowhere that I can do that, but yeah, the command is just surf and then x, y, and your function z. The function that I'm using here is just the tangent of x times y squared minus 2y minus 10, just to get some interesting shape. So it basically color codes things depending on the actual value of your function. In this case, that would be like the actual height of your z. So we got, I guess I don't know which way is which, but you know, x, y, and then z. So the mesh function and the waterfall do approximately the same thing. They just give you kind of a different visual surface, but they work the same way. Again, they're still color coded depending on the height, and it just, I'm not exactly sure what the difference is between the mesh and the surf other than the color, but the difference between the mesh and the waterfall is that these don't actually plot the column lines, whereas this one does. So you get kind of like a grid thing going on, whereas this one, you just get like slices. And then there is the contour, which will give you a two-dimensional, yeah, I think it would always be two-dimensional anyway. Two-dimensional contour where each of these lines represents a point where z does not change. So it's constant all along this thing, right? Which would be, you know, kind of like along this little bend right here. So if you just go around that, z doesn't change at all along this line. So that's what the contour plot tells you. And that's it.
Let's thank London. Questions? Please.
On that last one, the contour,
Yes.
if it's like there's a constant z along those lines,
Yes.
why can't it just be plotted as like an x and y?
It is. I'm not exactly sure, because there wouldn't be any reason
it is,
to
but it's
plot it in 3 dimensions. Because yeah, I mean, if you look at it, it is just a plane going
Right.
through there.
So maybe the box is just for looks.
Yeah, it might be. I honestly don't know why they would do it that way. Because I mean, a contour plot is inherently 2-dimensional.
Right.
I don't think I've ever seen a 3D one. That would be kind of weird.
Just curious.
So you can rotate in such a way that you look from above.
Oh yeah.
Maybe
I
with the
suppose.
dimension. Questions? I have a comment.
Yes.
Scroll back to one more. So here, plot 3.
Mhm.
it's not. It is not. What you are showing, it is a use of a command for not right purpose. Right
Okay.
now you have a one function of 2 arguments, but plot 3 is for 2 functions of 1 argument. If you are remember classical mechanics from high school or physics, it is a trajectory with 2 positions like x and y as 1 t. So argument is time, and there are 2 functions.
Okay.
Okay? More questions? If not, let's thank once again. So next presentation is by Christian Nilles, who will tell something that is really important when you want to sell your figures, how to format them and make larger fonts and make them visible. As you already see in these printouts, if the fonts are not big enough, no one will understand a thing. And same with scientific journals, which you may think of in your future career. If you miss to enlarge the fonts, people just will not understand you or will not accept the paper. So Christian will help us to avoid this complication.
As I said, I'm helping you to sell figures. So, this first off, we'll start off with the background of figures. What I mean by the background of this one, we're talking the outside border of this. So you can change the colors and the titles of the graph by just typing in your figure name there. Then, as we saw in Landon's PowerPoint, you can have 3D figures with those color schemes. Well, you can change those color mappings by clicking down on that drop-down box and clicking one of like a whole bunch of them. And then, as I said, the area around this can be changed with this drop-down box right there. Now we're moving on to axis titles and the figure backgrounds. So if you want to change around what how the figure they easily read the data and stuff. Also, if you want to add the axis titles, you have these tabs that you click on each one coordinating to one of the axes. So if you want the x-axis, then you click on the x-axis tab, and then you go through and fill out how you want to do it. X labels where you should get to see where the label is. You go through for each axis you have. You also have the fonts. As you click on, you can change what it looks like. So you can have Helvetica or something, or the font sizes. Then move on to the numbers around it. There's a drop-down box that you can select to change the color of those. Then you also have the color of the graph, and what I mean by the color, I mean you see all this white here, you can change the color of that.
Background.
Yeah, it's weird to figure the 2 differences. Then you also can add grid lines if you want it by clicking on each one of these boxes. So if you have 3D, that's why you have a Z, but then if you have just a 2D, you have the X and Y. And then the box, what the box means, come on, is this outline all the way around it. If you unselect that, that disappears. So now we're moving on to how to change how the line looks. So first off, we have the line styles. Each next slide, I'll show you the drop down of how the differences are. But you can have dashes or other variances of it. Then you have the marker types. See each one of those. You can change what those shapes are. Then you can also change the sizes of those markers by using this drop-down box right there. Then the color of those markers. Then you have the color of the line. So you can see blue, we can change that up. The thickness of the line is determined by the same way as you would do the marker. And then you also have different plot types. So you can change, like, it would have a line going cutting across, and you can have one that fills it all in, or there's do a bar graph version of it. So as I said, the options: bar, area, stairs. These are all the options if you click on that drop down. Then the line styles, you have dotted, you have other ones. Mainly you want to use solid. Then you also have the different types of markers you can put down, as you can see there, diamonds, other shapes. And then, any questions?
Questions? If no, it means crystal clear. Thanks much. And we have 3 presentations for 10 minutes. Next one is Breiden Wade, who will expand our power in visualizing things. So he will show how to go from just still images to moving pictures, cartoons, animations, scientific movies.
All right, so this is much less daunting than it probably sounds. I was a little worried that I got this one, but so also this dollar symbol just means that it's code that can be directly put minus the symbol. So first you have to, if you want to save the object, you need to create what's called a video writer object, which is a method within MATLAB. So it just has that in your file name, like MP4s. So, and then you need to open that object after creation, much like Java, like an object-based system. And then you can define an initial function just for kind of your own sanity. It's not necessarily to create the motion because you only see it for a fraction of a second anyway. But so like Landon said, and I forget who else, that you can define some domain. So I let mine go from -100 to +100 in increments of 0.1. So very straightforward. So then the meat of the animation takes place within what's called a for loop. I don't know how many of you have computer programming experience, but for loops are very common. So you just define some variable, I call it k, where k is an integer. I guess it doesn't have to be an integer, I kind of played around with it too, but integer makes more sense. It goes from 1 to 500, so and you can, again, for sanity reasons, you can turn that into some abstract time. So I just took it to be 0.05 times that integer. And then for every for loop, you must have an end for the loop, and that varies between different computational languages. But for this, you definitely need an end. And then don't forget your semicolons as well. Kind of important. So then, as before, we had just have a simple plot function. And so the animation occurs within the for loop because it loops the for loop and plots it every time. And so that's just the animation itself. And then some cool stuff you can do, you can change your axis. But that's fancy. You don't need that. And then at the end, you need to save the frames to the video file. So you need to store each image as a different one. And you can use the method getFrame from just a global variable and save it to some local variable current frame, like I called it. Then write it using the video object, and the current frame will write it to that MP4. And then, as always, you should close your open things and files and stuff. Okay, so then that's pretty much it. So this is the one similar to what Dimitri emailed out, just a sine wave moving. But I thought it'd be a little cooler to do something. So this is kind of what we solved for if we take an electron in free space in a roughly Gaussian. It's very peaked, and then over time, it definitely expands. So if you let that go to infinity, it will be about 0. All right, that's it.
Okay, so questions. It is something that we all will do in class, so take it seriously. It is a well, I don't know most, but one of the most important practical skills.
And he blew up this slide actually on the back of a whole sheet of paper, so you can really easily read it.
So open file, and what Breiden didn't mention, but it is sounds self-evident. After I will ask and answer question at the same time. So after his code is done, this file pops up in the directory where you run the code, and then in the PowerPoint you just insert video object, and then you will be able to play same way as he did right now. More questions to Breiden? If not, thank you once again. So next presentation is by Hanna Fanous, and she is following Breiden in the following sense. We are going from visualizing to programming. and there is no reason to do programming without saving data or reading data. So how to save outcomes of your scientific computation into files that you can send to your parents on a holiday.
Okay, so yeah, I'll show you guys how to save variables into file. And then if you save those variables and you clear them, how you can recover them from files. So first, just saving the variable into file. This code I circled in red is how you would do it. And your first x is the name of your file, but I just named it the same as the variable because it's easier. And the second x is the variable you're saving. And then if you want to know where it's being saved, you can type in pwd, and it'll come down and tell you where. But it also says like right up here where it's being saved, and it'll create a MATLAB folder in your documents under your name. And then you can go with that. And then, so I just typed in who to see who my variables are. And you can also see like over here, all the variables. And I'm gonna clear them, and they're cleared, and all the variables are gone, but my file x is still saved. And then so we can load x back now as a variable. And then, so that thing I circled in red, that command, I loaded x, the file x, and renamed it as x again. And then I had another, like a matrix A saved as file, and you can rename it as whatever you want when you go back and load it back in. So I just named it B and loaded in A as B, so now it's the variable B over there. And I forgot to take pictures of this, but when you go into the MATLAB folder, you can like double click on these text files and they'll show up in a notepad, and then you can see them outside of MATLAB as well. Yeah.
Okay, thanks, Hanna. Questions? It was so quick that I kind of missed. Did she show how to read data into MATLAB?
Like read the files themselves?
Yes.
I forgot to take a picture of that, but you can just go into your MATLAB folder, like it'll create a folder under your name on the computer, and then you can go into that folder and just like double click, and it'll pop up in a notepad, and then you'll see, right?
If your colleague has sent you data, numbers, and told it is an important function, plot it for me or do some mathematical processing with it, and you wrote a code, you're not going to type numbers like 16-digit numbers. You need to read the file. So how do you read the data file into MATLAB?
It's a good question. I'm not sure.
Read means load it inside. Which command does it?
So the loading command?
Yes.
Okay.
Okay, so it is here, right? If it is. So right now the x, this colored x, is a name of file, and this little x is a so this one is file, and this is variable. Okay. More questions? If not, let's thank Hanna once again. And last but not least, presentation by Wiering, who will introduce us to the art of scientific computing. So Breiden taught advanced chapters how to use the skills, but Luke will teach us how to start.
Alright, so today we're going to learn how to save, load, and run scripts. Scripts are super useful because if you have an equation that you use very often, or one that's so complex that it's kind of tedious to input, you can save it with the variable input so that you can just load it up, put in your variables, and it spits out an answer. So the first thing, you need to create a script. So on the Home tab, just a new script. As soon as you push it, you'll jump to the Editor tab. And with that, the Editor window comes up. So you have your command window, which is what you generally use to input it. So that'll jump to the bottom, and then the top will be the Editor window. From there, you can input an equation. Here I did one for finding the distance an object will throw at an angle with initial velocity. And I had my initial variables, and then my equation. And from there, we want to save it. So at the top of the editor, oh, you can't see it. That's the Editor tab behind the little window. there's a save button. From there, you click the save button, you'll pop up a save directory, write the file, the name, click save, and then you're all ready to go. Now you want to load it, so you just opened up MATLAB for the first time, brand new. Generally, it'll be in the current folder window, which is right here, but if it's not, you click on the Home tab, you have Open, goes to Directories, you can find your equation, then you load that, and then there it is right there. Now we want to run our script. So in the Editor tab again, you have the play button, which is generally what you want to use. Then you can also run, just down-click Run, or you can run it as you type it, but generally you have your equation written out, ready to go. And from there you click it, and it gives you your initial variables and inputs, and then your answer as you defined it. Any questions?
Okay, thanks, Luke. Any questions? Questions 1, question 2, question 3. Oh yes, yes.
Yeah.
How can you like pass variables from like into the script, and then can you do that? Like reference a script within a script by passing variable to it and use it as like a function externally?
Say that again? Sorry.
So say I'm writing one script, right?
Okay.
And you gave me a different script that just does an equation.
Mhm.
How can I, from my script, give your script some variable or something, and have your script give me back the answer?
I guess maybe I'm interpreting wrong, but can you just, that's just the variable. Oh, I see, okay. I think I know what you mean. So here, right now I have it clear all in CLC, which just clears the command window and clears all variables. If you remove that, it'll keep variables, so you can just have no initial conditions, and if you have variables that are currently have a value, in that, as long as you don't have the clear parts and you don't have them defined, it should run the variables as what is currently understood by the program. So if you ran a script and it spit out, let's say distance. So we have distance, so we have distance now, and we wanted to, we have another equation that defines distance in an equation to find something else. You just run that script right away without any initial conditions. And
so
yes, it would be able to.
So distance is like a global variable with all currently loaded.
Exactly. I wish I had the variable screen, because V, angle, G, and distance would all be defined now, and that would hold. And you could save that just as her PowerPoint showed.
Good question, correct answer, and it will, there is an extension if you want to go further. In addition to scripts, there are user-defined functions which have explicit arguments, and you can write them and store them into your directory as subroutine. Let's thank Luke once again. So have successfully completed the overview of basic skills for MATLAB, and I have a big hope that it will help us to go through the course material very quickly and efficiently. In any opportunity that comes, we will try to use scientific computation instead of boring mathematical derivation. I cannot promise 100%, but substantial amount. So right now you are certified experts in basic use of MATLAB, in doing vectors and matrices, in visualizing objects, and now you are all certified programmers. This, let me thank all presenters and announce the end of the meeting.